Hello, I'm Channa Bankapur. I'm going to discuss my solution to the lead code problem, maximum distance to closest person. It's today's problem in the October lead coding challenge. And the problem definition is as follows. So we have a row of seats, and in that some people are sitting, and in some seats no one is sitting. And we would like to see where can this person Alex sits, so that he maximizes the distance to the closest person, right? So the seating arrangements are in terms of zeros and ones. Zero indicates there is no person sitting there, and one indicates there is a person sitting there, right? So in this example, it's kind of very clear here, right? And Alex is going to sit at this seat number two. Seats are numbered, in zero indexed. So Alex is going to sit at seat number two, so that the distance to the closest person is two, right? And that is the maximum such possible value. So this is an optimization problem, and we want to maximize that, right? So, okay, the solution is not really complex here. See, Alex wants to sit in a place where there is a zero, right? There is at least one zero so that Alex can sit, and there is at least one person already sitting, so that there is a meaning to this maximum distance, right? So now, if we can find a range of zeros here, that means we have a range of empty seats, and Alex would like to sit at the middle of them, so that he is as far as from the closest person, right? So among all such ranges which are bounded by two people sitting on the and two boundaries, Alex is going to sit at the middle. Then Alex could sit at the middle, and among all such ranges of zeros, we can find the one which has maximum value, right? And that way we can find the distance of Alex's seat from the closest person, right? So in this case, 2 is that such an answer. Suppose if there is some exception case. Suppose if there are, say, a few empty chairs here in the beginning, right? So there are three of them. So in this case, Alex does not have to sit in the middle because there is no person at the left extreme. So Alex can sit at the left extreme seat, so that he is as far as possible from the first person, right? Who is at in this case index three, and three is going to be the distance to the nearest person or closest person in this example, right? And if there are four people at the other extreme, so Alex is going to sit at this place so that distance is maximized to four, right? So that's all we need to find. We need to find the ranges of zeros. If the range is either leading zeros or trailing zeros, we know that number of zeros itself is going to indicate the distance to the closest person. Or if there are a bunch of zeros here which are bounded by two ones, we need to find the middle of that. So if there are three, then the answer is two. If there are four, then also two. So essentially, it is, if that range size is say r, it's going to be r plus 1 by 2 floor of that. Actually, you could say r by 2 seal of that. Both are essentially same. All right. So let's look at the code. It should not be too complex to understand from the code directly. Right. So here is the code. It is well commented to understand. So we have an index called begin, which is typically the begin of the range of zeros. But yeah, maybe in the beginning it is not really that. But whenever we want to see find that distance, it is going to be the beginning of zeros. And we would like to find the first set of zeros which are leading zeros, and wherever begin is going to point, this is going to point to the first one. If there has to be at least one, so it is going to point to the first one, and this number indicates the first possible result. So I'm going to have a result here. Result is going to keep track of the optimal value. Now in this while loop, every time I start, begin may not be pointing to zero, but it could be pointing to one, or if it is anyway pointing to the end of seats, so we'll come out of the while loop. But if it is pointing, it could be pointing to a one. In that case, the first while loop is going to move that begin to first zero of that the range of zeros we are going to find. So now when we're out of this while loop, we are pointing to the first zero of the range, and end is going to start from there itself, and then it's going to move till it is going to point to the first one, right? Unless we are already at the end of the array. So when I come out of here, if there is a one here, and then a bunch of zeros, and then again there is a one, begin is pointing here, and then end is pointing here. So end minus begin is going to give me that size of the range. So as we already saw, end minus begin plus 1 by 2 is essentially a floor because it is integer division, and that's going to be the distance, right? Alex might sit at a distance of d from the closest person with respect to this range of zeros. Now we'd like to keep track of the best. So the best of whatever the result found so far and the d is going to be the optimal value so far, right? And then we're going to again move begin to this end so that we actually move on to the next range and then we can find it, right? So that's the idea here, and it should work, right? Let me run and then show. Let me submit and show. Right, it accepted. So it runs pretty fast. It is actually linear time taking algorithm. If you see here, begin always increases in this one, and end also increases. And in every loop, we are always finding the next range of zeros. So it'll never stop, and that's why this should take linear time, right? I think it's very easy to analyze that way. All right. So if you know any other way of solving, any easier way of solving, and a different way of analyzing the algorithm or the problem, please let me know in the comments. Otherwise, please like the video and then come and then subscribe to the channel. Keep solving a problem every day, and happy coding.